Today we're going to talk about the project management. Now, project management is a broad topic. We have an entire course here at Western dedicated to project management. It's a discipline and set of tools and concepts that comes in handy in a lot of different areas, not just operations management. But I've placed project management here in the syllabus for this course because one of the most common type of projects is setting up a new facility or new building at a location, and of course we just talked about facility location, so this seemed to be an apt point to talk about project management. One of the things I'll talk about first, just briefly, is how projects are different from conventional operations, both conventional manufacturing and conventional service operations, and talk about what makes projects unique. And then we'll mostly spend our time today talking about project scheduling. So if we have a project which consists of a large set of tasks which need to be completed in a certain order, how do we go about determining how long it's actually going to take us to complete the project? And also, how do we determine what are the most critical tasks in that project? Tasks that if we delay on them, we will delay the completion of the entire project. The newspapers are always full of news stories about some big transportation project that's been delayed and by months or maybe even years. And the nature of projects is that everything else can be going fine on the project except for a few key critical tasks are not completed on time. They're delayed, and that delays the completion of the entire project. So we'll talk about that and see how we can determine what those critical tasks are. Those tasks that are critical are usually referred to as being on the critical path. Okay, so we want to be able to identify the critical path, and to do that we're going to apply a technique called the critical path method. So projects, I've got a nice one-liner here. They're complex, one-of-a-kind, and non-repetitive. So that distinguishes them from conventional manufacturing and service. In a conventional manufacturing operation, you're churning out airplanes or aluminum or steel or amplifiers or CRTs or whatever. You're doing the same thing or a range of similar things over and over and over. Same thing in a service operation, whether you're running a hospital or a movie theater or a hairstylist. You're basically doing the same sort of tasks over and over. You have a limited range of products or services that you offer, and you do these over and over on a regular basis. Projects, on the other hand, are much more complex. While there's some broad similarity between, say, building one type of building and another type of building, there's a lot of variability from building to building. If we're talking about the project of building a facility, and because of that relative uniqueness and non-repetitive nature of projects, there's a whole separate discipline and set of tools for managing projects. So again, just examples of projects here: building construction, obviously, engineering design of some complex assembly, say like the space shuttle, something you're not going to be knocking off lots of space shuttles, or they didn't rather in the past. They had a few of them, but so in the first time they put them together, it was a unique one-of-a-kind event. A big marketing campaign, new software installation, all these would be examples of projects which are going to be fairly complex and non-repetitive operations. And also important to note is that projects, they have a beginning, there's a bunch of tasks that have to be completed, and hopefully you reach the end of the project. Again, rather different than making widgets of some sort, where you're making widgets today, making widgets tomorrow, and we'll be making some sort of widget hopefully years from now. Well, project management is a broad discipline, and project management is concerned not just with project scheduling, but also how you set up a team, that the project team that is going to manage the project, and the importance of getting together people from all different areas of the organization that need to have input into the project to make sure that it is successful. Again, these topics they talk about some in the text and talk about in greater detail in our project management course, but what I want to focus on here in the talk today is project scheduling techniques. So we're going to assume that a team's been put together, we have a project manager, everything's been properly organized, but what we have to do now is, after these tasks have been identified, that determine what needs to be done in order to successfully complete the project, how can we identify those most critical tasks and make sure that we get the project done as quickly as possible. So we have to identify each possible task in the project. Right? That's the first thing we have to do in coming up with a project schedule. We have to estimate the duration of that task, and also very important, determine the precedence of that task among all the other tasks. Right? So let's take a look at this little simple schematic down here. The representation of the project tasks that I'm using here is referred to in the text as activity on node. So each of these nodes, that's these little circles here, represents an activity or a task that has to be done in order to complete the project. So I've got task A, task B, and task C. And the order of placement here, plus the arrows, indicates the precedence among the tasks. These are the arcs. Okay, these arrows are also called arcs. So this says that task A has to be done before task B, and task B has to be done before task C. So another way of phrasing that is we say that activity A is a predecessor of activity B. It has to be done before B. And activity B is a successor of activity A. So a simple example of predecessor and successor activities. Think about getting dressed in the morning. You could think of A as putting on your socks, assuming you wear socks, and B as putting on your shoes. You can't put your shoes on until you put your socks on. So putting on your shoes is a successor activity of putting on your socks, just like putting on your socks is a predecessor activity of putting on your shoes. The little numbers over here to the right of the labels of the activity are to represent the time required, the estimated time required to complete each of these activities. So again, if we're not talking about putting on socks and shoes here, but some more general activity, suppose that the first activity is going to take 4 days, next one 2 days, and the third one here, activity C, is estimated to take 4 days, then clearly this very small project, which is just comprised of 3 activities, is going to take us, if our estimates are correct, 4 plus 2 plus 4 days, or a total of 10 days, because we can't start B until A is done, and we can't start C until B is done. So this very simple project just has 3 tasks, task A, B, and C, shows a lot of the important elements of project scheduling and what makes it difficult. We have not just the tasks themselves and the times needed to complete each of these tasks, but we have the precedence among the tasks. That's what makes the project difficult to manage. So let's take a look here at a slightly more complicated example, and we're going to work through this example in a subsequent video, and see how we can determine the minimum time needed to complete the project, as well as what are the critical tasks on the critical path. Again, but for now we'll just familiarize ourselves with this project. So this is a project which is comprised of 7 different discrete tasks, and I've got the tasks listed here 1 through 7, and here they're represented in the activity on node representation that they talk about in the text. And again, these arcs indicate precedence amongst the activity. So the first task that has to be done is 1. Once 1 is completed, I can start either 2 or 3. Right. I can start 4 only when 2 is completed. And then when 3 and 4 are completed, I can do either 5 or 6 in either order. And then once both 5 and 6 are completed, I can start and complete task 7. Okay. Now each of these 7 tasks has a certain length of time associated with it. So task 1 takes 21 days. Task 2 takes 5 days. Right. Task 3 takes 7 days, and so forth, all the way to task 7, which takes 2 days. Now the third column up here above, immediate predecessor, this is giving me the information that's contained in the arcs or arrows going from one node or one task to the next. So a blank line here indicates that task 1 has no immediate predecessor. I can do it first, or it must be done first, and nothing else can be done before it. If I'm doing a construction project, perhaps this is grading the land to get ready to pour the foundation. Then task 2 can be done as soon as task 1 is completed, because its immediate predecessor, 2's immediate predecessor is 1. And again, we see that information here in this arrow as well. Same thing with 3. 3 has an immediate predecessor of 1, which we see here in the arrow. 4 has an immediate predecessor of 2. As soon as 2 is completed, 4 can be started. And task 5 is a little more complicated, and we see that here with 2 arrows coming in. And we represent that in this column of information here by saying that 5 has 2 immediate predecessors. 2 things must be done before task 5 can be started. And those 2 tasks are task 3 and task 4. And again, we see that information represented here graphically by this arc and this arc. Task 6 has the same 2 immediate predecessors as 5 does, 4 and 3. And task 7 has 2 immediate predecessors as well, task 5 and task 6. So this is all the information we need, whether it's represented here in this chart or it's represented here in this diagram. This is all the information we need in order to determine what the length of time is necessary to complete the project and what the critical and tasks are and what the critical path is. Okay, so I'm going to end this video and pick up the discussion of how to determine that critical path and the length of time needed to complete the project on the next video.